Hello, today we're going to talk about vectors using their components. I'm going to start off by looking at the unit vectors. A unit vector is a vector that has a magnitude of 1 or a length of 1. If it is completely horizontal, we call that our unit vector I. If it is completely vertical, we call that our unit vector J. And we are going to write our vectors in terms of I's and J's. All right, so we're going to start off with problem number 1 here. We want to write that vector using components. So I look at it and it is vertical, 1, 2, 3 units. So I write 3J. If I look at this one down here, it is 1, 2, 3, 4, 5, 6 units in the horizontal direction. So I write 6J. If I look at 3 here, you can tell that it is 1, 2, 3 units long. It's horizontal, but since it's going left, we write minus 3J, or sorry, 3I. And similarly, this one is going down. The arrow points down, so we write negative. It's 2 units and it's vertical, so we write negative 2J. All right, so let's draw these if we're given vectors. So 3I would be 1, 2, 3. And the beauty about these is we can put them anywhere we want. All right, just as long as it is all horizontal, I can put it right there. If I want to do negative 7J, I would just count 7 units. So 1, 2, 3, 4, 5, 6, 7. Since it's negative, we need it to point down. And so that is negative 7. Oh, I thought it said J. Sorry, my fault. It says I there, so I needed to go 7 units this way. 1, 2, 3, 4, 5, 6, 7. So that's negative 7I. And the negative 2J, we're just going to go 2 units in the Y direction. And we want to go down. So again, we can put these wherever we want, just as long as they're 2 units long and their direction is going. So if it's negative, it's going to go down or to the left. And if it's positive, it's either going to go right or up. All right, so now we're going to draw the given vectors. So if I look at 3I plus 2J, that means let's look at them separately. So if I draw 3I out, 1, 2, 3, that would be 3I. And if I draw 2J, that would be 2J. And if we remember from yesterday, when we add vectors, we put the tail of one at the head of the other, and we connect the tail to the head, and so I have this is 3I plus 2J. Now again, it's not necessary that it stays there, but it needs to have that length in that direction. Okay. Oh, let's try the second one here. So negative 7I means I have to go 1, 2, 3, 4, 5, 6, 7 units in the left. So this is negative 7I. And then 5J would mean I have 1, 2, 3, 4, 5. And if I add them, I move head to tail, and so my resultant vector would be that length there. A lot of times we do position them So they are at the origin, and we will look at that later so we can start to look at their angles. Um, it's somewhat helpful to put them at the origin, but it doesn't have to be done. All right. Next question says, write the vector as a sum of its components. Find the magnitude of this vector. Okay, so remember, first of all, let's find the components. So I need to figure out, well, how many units did it go right or left? And it went 1, 2, 3, 4 units to the right. So that's going to be positive 4i. And it went 2 units up. So that would be 2j. And so if you add them together, you would just write 4i plus 2j. So, and that's the answer to this question right here. Magnitude, another word for magnitude, remember, is length. So we want to know how long that is. Well, we've got ourselves a nice little right triangle here. So all we have to do is Pythagorean theorem. 4 squared plus 2 squared equals your c squared. So I have 16 plus 4, which is 20, equals c squared. Take the square root, and you get c is equal to the square of 20. And then we need to break this down and write it in the most simplified fashion. So some of you may look for prime numbers. So 2 numbers that multiply together to give you 20. Some of you might say 2 and 10, and then 2 and 5. And you see that you have a pair of 2's. So you can take that 2 out, and it becomes 2 root 5. Or you can also see it as find the perfect square in there, 4 times 5. So the square root of 20 is the same thing as the square root of 4 times the square root of 5. And we all know the square root of 4 is 2. So our magnitude is 2 root 5. However you break down radicals is up to you. Just you either use the tree or you use perfect squares. But it's just like a fraction. You would never leave 2 fourths. You'd always write 1/2. That's the same thing with the square root of 20. We don't want to leave it the square root of 20. We want to break it down to 2 root 5. And all that means is the length of the vector here is 2 root 5. All right, what angle does this vector make with the positive x-axis? So we're looking for that angle there. We already know this length is 2 and this length is 4. All right, so we just go back to SOHCAHTOA, right triangle trig, because we know that's a right angle. And if I have the opposite side and the adjacent side, hopefully that tells me I should be using tan. Tan of 2 fourths, or 1/2. And then to find that angle, I inverse tan. And if I go to my calculator and solve that, I will get theta equals 26.6 degrees. So what angle does it make with the positive x-axis? This is the positive x-axis in the vector. That is 26.6 degrees. All right, write this vector as a sum of its components. So I got another example here. So now we have to be careful because I didn't go right, I went left, so I have to write negative 2i. And then I went up 3, so that's 3j. And so this vector, as a sum of its components, is going to be negative 2i plus 3j. Okay, same vector. We now need to find the magnitude, so we go back to right triangles and just say, okay, I've got negative 2 squared plus 3 squared. Make sure you're squaring that negative, so it's 4 plus 9, and you get 13. And so therefore, our magnitude is just the square root of 13. You could try to break the square root of 13 down, but we know that's a prime number, so you can't break it down. It's approximately 3.606 units long. So if you look at that, you can see, okay, that could be a little over 3 units long. Now let's find the angle that it makes with the positive x-axis. Okay, so this is the positive x-axis. We're looking for that angle there. So again, we drop down the right triangle. We use the idea this is 3, this is 2. I probably would just say positive 2 because I'm just going to find that angle right there. And so when I do this, I do tangent of theta equals 3 over 2. And I get inverse tangent of 3 over 2, and I get that for a number. If I would have used negative 2, so if I have 3 divided by negative 2, you're just going to get a negative angle measurement. Regardless, neither one of those are our answers. We are really looking for our reference angle here, which is 56 degrees. Okay, which that's not our angle we want. We want this big angle here, but we can see that all we have to do to get that is take 180 and subtract that 56 degrees. And so if I do that, I'm going to end up with 124. All right, adding vectors using the components. So now we're going to get away from the pictures and we're going to use just the equation forms. Okay, so if I know vector E is 2i plus 7j and vector F is 4i minus 3j, I don't know why the arrows fell below here, but put them on top. If I add them together, what do you think we're going to do? All you have to do is add your like terms, just like you did if they were x and y's. So all I'm going to do is add these together. So 2 and 4 make 6. So E plus F is going to be 6i. And then add 7 and negative 3, 4j. Now we're going to go back to another example real quick. Do this one before I do it. Make sure you understand what we're doing when we add. And again, I don't know why those arrows decided to jump down. Okay, angle vector B plus D is just going to be negative I, 1i, right? Because 4 plus negative 5 is negative 1. And negative 3j. Negative 9 plus 6 is negative 3. Okay, now we're going to go back to the same ones we did with pictures, and I might, recommend drawing a picture if it helps you to find the magnitude and the direction. So we just found that BD was negative I minus 3J. So if I look at that, that means I went left 1 unit, and I went down 3 units. Okay, so my triangle looks like that. This is 1, this is 3. To find the magnitude, it's just the Pythagorean theorem. 1 squared plus 3 squared equals my magnitude. Go back to the notation we used yesterday. So 1 plus 9, which is 10, equals your magnitude squared. So therefore, your magnitude is equal to the square root of 10. Last question is they want the direction. So the direction of your vector is that angle right there. So if I want to find the direction, I start out by looking at tangent of the angle is equal to 3 over 1. I do inverse tangent of 3 over 1. Go to my calculator here. Inverse tan of 3 over 1. And I get 71.6. But please know that is not your answer. That is, again, your reference angle. And we need to get this whole big angle, which means I have to go ahead and tack on 180 degrees. And so I end up with 255. Or sorry. Sorry. 251.5. Round up. All right, if you think you got the hang of it, we're going to try another one, but this time we are going to now use the magnitude and the direction and go backwards. Okay, so if you know the magnitude of your vector is 12 and you know the direction is 72, can you write it as a sum of its components? So when you're looking at it, I would say, okay, well, how am I going to figure this out? I would drop down my right triangle. This is my J component. This is my I component. If you have this angle here, this is the opposite side. This is the adjacent side. And you have the hypotenuse. So now we're just going to do trig. Right? So when looking at this, to find the opposite side, I know that I'm going to have to use sine. So sine of 72 equals, we'll just call this y. Y over 12. And I go find that by just taking 12 times sine of 72. Hitting enter, and I get 11.4. Okay. Similarly, to find the x part, we're just going to do cosine of 72 equals x over 12. Go to your calculator. 12 times cosine of 72. Hit enter, and you get 3.7. All right, so when I want to write this now as the sum of its components, I can just simply say, okay, well, my J is 11.4 and my I is 3.7, so this is just going to be 3.7I plus 11.4J. Now, there is this formula here, which looks terribly confusing, but it's exactly what we just did, right? We looked at taking the magnitude of the vector times cosine theta, and y equals the v sine theta, the magnitude of vector b. So that's exactly what we did here when we drew in our right triangle. Notice the y was sine and the x is cosine. That hasn't changed. So you can memorize this formula, or you can just always draw your pictures and do your right triangle trig that you've been working on for years. All right, try this next one on your own if you can give it a shot. We got, again, an angle measurement and a magnitude, and we want to write it at the sum of the components. So stop it, give it a shot, see that you can do it, and then start it back up and see if you got the right answer. All right, so here we go. I'm going to say that this angle I know is 142. So then this angle right here is 180 minus 142. 38 degrees. And so therefore, this is going to be the x, this is the y, And so you're going to write cosine of your angle times your magnitude of the vector, which is 8. Again, if you're writing out the whole equation, that's fine. Cosine theta equals opposite side, or sorry, adjacent side, which is x over 8. You're just doing one additional step. And so if I type 8 cosine of 38 into my calculator, I end up with 6.3. Now here's the tricky part. This is not positive, it is negative. So you're going to have to, when you write the component, you're going to have to write negative 6.3i. A way to get around that is not even have to worry about this 38 degrees. If I put in 142 here instead and type it in, 8 times cosine of 142, and this is where the formula is kind of nice, you already get negative 6.3. Similarly, if I do the y the same way, I take the magnitude of the vector and I do sine of my angle, which is 142, and I type that in, I will get 4.93. And so therefore, this is going to be plus 4.9j. Okay, let's try another one. Draw the vectors. C is 14 units at 30 degrees, and vector D is 5 units at 345 degrees. Okay, so 14 units at 30. We'll just say this is 14, and this is 30 degrees. 345, or 45 would be right about there, and it's only 5 units long. So I'm just going to do that. Write it as the sum of its components, so just what we did before, and you might be using the formula now, so you know it's just the magnitude of the vector, cosine of the angle, that's your I part, because that was the x, remember, cosine's x, plus the magnitude of the vector, which is 14, sine of your angle, again, that's j. That's going to be this blue vector here. I guess I should have wrote it in blue. So then I just go figure out what that is. This is an exact value one, so we could actually use our exact values, but I won't. Cosine of 30 is root 3 over 2, so this is 12.12 I plus, and then 14 sine of 30 is just 1/2, so it's going to be 7, right? Okay, so this component, this vector right here, this blue one, is this vector right here in component form. And now let's look at the green one. Again, if you're using the formula, you take the magnitude of your vector. The x part is cosine. And then we can just use 345, and we don't have to worry about the positive, negative. And the y part is sine, and that's 5 sine of 345 j. So again, go here, do 5 cosine of 345. Again, we could use exact values, but they're going to give you square roots, and I want decimals. So 4.83, we're going to say. And if I put 5 sine of 345 in my calculator, I'm going to get negative 1.29, which should make sense because you're in the fourth quadrant and you know y is negative. So then I change that plus sign to negative 1.29 j. And so now this is the component form for this green vector right here. Next question wants us to take these two vectors and add them together. Okay, so if I were to do that, just take this picture with me. Okay, we're going to leave that there. So if I want to find that, I can take this and move it up here. Let's move this over. And then my resultant vector is going to be that angle right here. Remember, this was C and this was D. So that's my resultant vector. We have the equations here, so I'm going to move them over as well. Bring them over. Okay, so this was vector C and this was vector D. And so if you want to add them up, you just go ahead and add their decimals up. And so I'm going to have C and D added together. Just make myself a little bit more room here with this problem. And so add the I components up, and you're going to have 16.95 is what I've got, right? Add those together. That's your I. All right, just added those two together. And then for your J, if you add the 1.29 and the 7, remember 1.29 is negative, I'm going to get 5.71. So that is the components of the resultant vector. Now we need to find the magnitude and the direction. So numbers are getting a little bit uglier, but we can still do this. So 16.95 squared plus 5.7 squared, and take the square root will be my magnitude. If I run to my calculator and plug all that number in, I should get 17.89 units long. And then if I want my direction, so that's saying this red line right here, red vector, is 17.89 units. But you can see this, if this is 14, you can see the red one is slightly longer, so that would make sense. And then if I want the direction, I need to find out, if I were to drop it down and use the right triangles, remember you can do tan, and we also remember that tan is y over x, right? So the y part is the j part, so 5.71, divided by the x part, which is 16.95, and we inverse tan that, inverse tan of 5.71 divided by 16.95, and we end up with 18.6. And that seems like a logical answer if you look at the fact that from the positive x to the blue was 30. That looks like it's pretty close to the middle. 15's the middle of 30, so 18's pretty close there. And that ends our lesson on vectors and its components. Give the On Your Own a shot, and we will work with more of these in class tomorrow. Have a nice night.